For the visual inspection for your HAPSITE, the first thing is just, is there no major physical damage on the instrument? Past that, if you've recently got it back from a repair, you want to check if all of these screws along this top portion and then another set of screws along the bottom of the HAPSITE are roughly tight. Next up is your gasketing material on this front panel. When you're opening up the front panel, try not to use your fingernails, simply your thumbs, pulling straight back on the front panel. There's a lot of times little nick marks if you use your fingernails to open that. If there's any breaks in this gasketing material up here, all the way around, then your instrument is not ready to be deconned and this has to be replaced. After that, we have static pins that are meant to read your internal standard canisters. There's two options or two places for static pins, but only these closest to the HAPSITE need to be in place. If they simply depress really smoothly, then they have no problem and don't need to be replaced. Lastly, it asks you to check if your concentrator is installed correctly. I'm not going to do that because it introduces more risk than is needed, and if your blank method runs fine later, then your concentrator was installed correctly. For section 2, the first 3 values you're going to need to find on the main screen of your ERIQ software. 2.1 asks what the software version of the computer is, so up here I'm going to click Help, and then I'm going to click About ERIQ, and my software version is 2.33. The next 2 questions ask about the ion pump hours and the GC column pressure. So I'm going to click on my HAPSITE down at the bottom, and then I'm going to click on my status icon up here. For maintenance is where I'll find my ion pump hours. So that's this number right here. I have 40.54, so 40 minutes, 54 seconds. And for my GC column pressure, that's going to be under pressure flow and offsets, and this value is 87. This value is also not grayed out because it helps adjust your retention times if they're failing later on in this run. To find the software version on your HAPSITE, you're simply going to click your HAPSITE icon in the top right corner, and then your HAPSITE icon on the far right, and then over here where it says software version, mine is 2.4.1, that's where you'll fill that out. Another question that's a little tricky is when it says, does the instrument have only the latest methods? Generally, if you've got thermal desorption methods, you should be up to date. For the tune section of the HAPSITE PMCS, we first need to check if our tune completed. So let's click on the HAPSITE icon at the top right-hand corner. And then we can see this tune status in green that says OK right beneath it, which means my tune passed without any issues. One of the questions on here is outside of this tune status button, and that one's going to be what are the hours on the neg pump? So let's go ahead and answer that one first before we come back to the tune status. We can click on our heaters, and then down here I have my neg selected, and on the far right hand side it says on time. This on time value is what you're going to record for your neg hours. Going back to my tune status, I can pull the rest of the values from the tune report button in the lower left hand corner. The first question, are all masses okay? On the left-hand side here, we see a listing of masses. They're just different mass fragments that are in your tuning standard, and if they fall between their low and high value. If they fall between their low and their high value, they're somewhere in between those two numbers, they're listed as okay. For our next, we're going to be looking at our base peak gain. It wants to be between 0.4 and 0.6. My measured base peak gain right here is 0.45, so it passes without any issue. You want to be closer to 0.5, but it's really not that big of a deal as long as it's within the range. The next thing is going to be our pressure. It wants to be below 3e to the negative 3. So mine is 3e to the negative 4. This negative value, you want it to be as negative as possible. So negative 4 is actually better than negative 3, and so on. For the left-hand side value, you want this one to be as low as possible. So 1e to the negative 4 is better than 3e to the negative 4. Either way, mine passes. Occasionally on this value, you'll see a reading that says either acceptable or below gauge range. Both of those values mean the same thing, and it's actually a very good vacuum. It's lower than the machine is actually capable of reading. So that's also a passing value. Next, we're going to be looking at our baseline and threshold. Those are found down here below. Mine's a little bit off for my threshold. I'm at 500, my baseline at 200. Both of these ideally should be below 300 to be passing without issue. My machine's still working fine, so I'm going to continue using it, but this could possibly cause problems if you're seeing other issues in your HAPSITE runs. Next up is my resolution and ion energy for my 117 peak. We're only checking the 117 peak here at the very bottom of the screen because it's your base ion. It's your primary ion in your tuning standards, and everything else, all these other ions, are based on the size of this 117 peak. So 23,330 and 164 is what I'm going to record here. For section 4 of the ER PMCS guide, it's going to ask about your ER survey method. The ER survey method is only checking if the mass spec portion of the HAPSITE is working and if it's able to reference an internal library. So we're going to start run survey. At this point, a pump is going to start up to be able to pull sample through the tip of the probe. And you have to think when sample enters the probe, it's got to go all the way through this heated line, in through a valve port system, and then to the mass spec on the inside. So there's a bit of a delay from when I enter the sample to whenever the sample shows up on the screen. Because of that, when I'm taking a sample, I don't want to just hold it in until I see results. Instead, I'm going to do a quick half-second press and then wait for about 2 seconds to see results. Now that my survey is reading results, I'm trying to establish a flat baseline. So here, this line will be jagged up and down, but eventually it's going to level off. So it looks like I'm roughly leveling off at a little above 200,000. Now I'm going to take the H side of my stimulant, which is wintergreen oil. You can use anything else. Essential oils often work pretty well. I'm going to tap it about a half a second, and then I'm going to wait for a response on the screen. Once I see that spike go up, it should start clearing back down, and it'll get flagged with a blue triangle. That blue triangle should say methyl salicylate, and when I want to know if I can shut off my survey method, I'm waiting for my tick value in the upper right-hand corner to approach my starting value, which was low to mid 200,000s. It might not make it all the way there, but if I go 10 to 15 seconds without seeing an additional blue triangle, I can say that my survey method has successfully identified and cleared out. For section 5 of your PMCS check sheet, the blank method, you simply need to make sure that ER Air Tri-Bed ppm standard is selected. That's the one that only pulls 5 mLs of air for analysis. Then you can hit Run Analyze on the front panel and just wait for 10 to 12 minutes or so. For the blank method, you do not want any sample to be taken into the probe. Ideally, you only want to see 3 peaks show up. Your air peak at about 45 seconds, your tris peak at about 1 minute and 20, and your BPFB peak at about 3 minutes and 45 seconds. However, depending on your environment, you may see different contaminant peaks. The most common of these are sulfur dioxide. It's a common environmental contaminant. Toluene will show up if you're near a flight line or airport. Limonene is common in some cleaning supplies or soft drinks, and methyl salicylate could have just been left over from our ER survey. These by themselves do not indicate a failure of the instrument, only that your current environment contains those chemicals. The main thing I'm looking for, though, is my BPFB peak to be very close to 3 minutes and 45 seconds. Since mine's a little bit early in this data file, I would need to adjust my column pressure from part 2 down very slightly. For section 6 of the PMCS guide, it's asking about library searches. So I'm going to open up the blank method that we just ran. This really could go for any method or any data file that you've ran. I'm going to double click anywhere in the chromatogram. In this case, it's going to be the BPFB peak. And when I hit search NIST/user over on the right hand side, it should reference the NIST library and populate a hit down here below. If for 6.2, I want to check if my AMDIS library is working, simply click the AMDIS button up top, and it should populate our tris and our BPFB hits. For the performance validation section of the PMCS guide, the first thing we want to do is change our analyze method by hitting select method on the front panel and then going all the way to the bottom to where it says GCCBQC. This method pulls in the largest volume of air and is the most dangerous for the HAPSITE. You should only run it if you're running a performance validation. Once I've selected that method, I can go ahead and hit Run Analyze. While my Run Analyze is prepping, I should get my syringe and my 5-part standard ready, and I'm going to pull up exactly 1 microliter into the syringe. To do that, I'm going to pull the plunger back to about the 1 microliter mark, so I have a pocket of air out front. I'm going to put it down into the liquid. And then I'm going to move that plunger back another microliter so that inside the syringe, I have exactly 1 microliter of liquid. If you want to check your results, you can kind of hold it up against the light in your own reference, and you can see a slightly different shade between maybe the 2 and the 3 or the 1 and the 2 markers on here. But you want that amount of sample to be really close, almost exactly 1 microliter. The first thing that's running on the front panel of my HAPSITE is something called a line purge. You do not inject during that 1-minute line purge, but after the line purge finishes, which is about to happen, it starts an event called the conc fill, or the concentrator fill. This is when your sample is actually being filtered through the concentrator. So I'll grab my probe. I'm going to hold it roughly vertical, and the syringe should drop down all the way until you have glass against metal. At that point in time, I need to inject incredibly slowly on the back of my plunger. In my head, I'm imagining that liquid coming out and just forming a bead or a bubble at the tip of that needle. And as air flows past to that bubble of sample, it slowly gets evaporated and brought down into the instrument, slowly instead of all at once. So at this point, I've completely injected all of my sample into the tip of the probe, and I have nothing to do but wait for this method to finish. Once the CBQC method is finished from your 5-part standard, you can start filling out the PMCS check sheet. To do that, we're going to go to this View Reports button in the lower right-hand corner, and then we're going to want to view our quant report. If I scroll down in this list, I can answer my first question, which is what is the retention time for my TRIS HAPSITE standard? Right here, it looks like I have 2 different answers. So the first one, my record number 1, mass fragment 69, TRIS HAPSITE. It listed as 118. However, that's a predicted retention time. The values that you want to fill out are right below that over here. So record 1, mass fragment 69, retention time 1 minute and 16 seconds. So don't fill in the values for the actual chemicals up here. You're going to follow it down for your run's actual values. So TRIS 116, BPFB 403 for my instrument. If I go down to the very bottom, you can see your actual 5 parts from the 5-part standard. Here are their values. If you want to know the chemicals that they're coming from, it's right above. So if I want to get my concentration for fluorobenzene, I follow mass fragment 96 down. And I see fluorobenzene is here at about 7.9 or just below 10, so it's possible that I under-injected during my method. The one that's really difficult for the CSTs to pass is diethylmalonate. Oftentimes your standard is missing some diethylmalonate, or it leaves solution, or it wasn't made correctly. So I see a lot of CSTs fail diethylmalonate, not because of a problem with their instrument. Usually it's because of a problem with their standard.